Data preprocessing cleans and structures raw data to improve machine learning accuracy. It removes errors, fills missing values, and standardizes formats, ensuring models learn real patterns and deliver reliable and high quality results. Hello everyone and welcome to the data preprocessing and action part of machine learning with Python. My name is Narendra Kumar Sharma. In the previous video, we covered first few essential data preprocessing tasks. We will cover the remaining steps in this video. Let's proceed to the next tool in our data preprocessing toolkit, which is about encoding categorical variables. Encoding categorical variables is a critical data preprocessing step in machine learning because most machine learning algorithms require numerical input to perform mathematical computations. Let's first understand why we have to do this. As we can see, this dataset contains one column country with categories France, Spain, Germany. It will be difficult for machine learning model to compute some correlations between the features and the outcome purchased, which is the dependent variable. And therefore, of course, we will have to convert these categorical variables into numerical values. So one idea would be to encode France into 0, Spain into 1, and Germany into 2. However, if we do this, our future machine learning model could understand that because France is 0, Spain is 1, and Germany is 2, there is a numerical order between these three countries, and mostly it could interpret that this order matters. Whereas, of course, it is absolutely not the case, right? There is not any numerical order between these three countries, France, Spain, and Germany. So we want to avoid the model to have such an interpretation because that could cause some misinterpreted correlations between the features and the outcome which we want to predict. Therefore, we can actually do much better than just encode these three countries into 0, 1, and 2. And the better thing that we can do is actually one hot encoding. And one hot encoding consists of turning this country column into three columns. Why three columns? Because there are actually three different categories in this country column. If there were, for example, 10 countries here, we would turn this column into 10 columns. And one hot encoding creates binary vectors for each of the countries. Let me explain this right away. So very simply, France would, for example, have the vector 1, 0, 0. Spain would have the vector 0, 0, 1. And Germany would have the vector 0, 1, 0. So that there is no numerical order between the three countries because instead of having 0, 1 and 2, we would only have zeros and ones and therefore three new columns. We are basically going to replace this country column by three new columns containing the zeros and ones and coding each of the countries. That is called one hot encoding, and that is a very simple, useful and popular method to use when pre-processing your data sets containing categorical variables. So that's the first thing that we will do here for this country column. And then there is this purchased column that has labels, known numerical values with yes and no, and we will actually have to replace them by zeros and ones. And that is totally fine for the dependent variable as long as it's a binary outcome. It will actually not compromise the future accuracy of the model if you just replace no and yes by 0 and 1. First, let's start by one hot encoding the country column. Let's go back to our notebook. Let's create a new code cell for this new step, encoding the independent variable country. To do this, we are going to use two classes. The first one is the column transformer class from the compose module of the scikit-learn library. And the second class is the one hot encoder class from the pre-processing module of the same scikit-learn library. So first, let's import these two classes. Import column transformer class from the compose module of scikit-learn from sklearn dot compose import column transformer and then import one hot encoder from pre-processing module of scikit-learn from sklearn dot preprocessing import one hot encoder. The first step is to create an object of the column transformer class. We are going to create a new variable which I'm going to call CT. CT equals to create an instance of the column transformer class. CT create object of an instance of column transformer. Now we have to enter two arguments. These two arguments are the first transformers, where we will specify what kind of transformation we want to do and on which indexes of the column we want to transform. And the second argument is the remainder, which will specify that we actually want to keep the columns that transformation won't be applied to, meaning age and salary columns in our dataset. Let's first enter the names of these two arguments. The first one is the transformers. Transformers equal to this argument is used to specify list of tuples specifying the transformer objects to be applied to subsets of the data. The next one is remainder. By default, only the specified columns in transformers are transformed and combined in the output, and the non-specified columns are dropped. For the transformers, we actually have to specify three things: name, transformer, and columns. We have to actually input all that in a pair of square brackets and then parentheses. First parameter is the name of the transformer. Name it encoder. Second parameter is the transformer. Okay, we will use one hot encoder. And the third parameter is the indexes of the columns we want to transform. In our case, it is the first column, the country column, index 0. That's all for the first argument, transformers. And now the second argument, remainder. Set remainder to pass through. Pass-through is a code name that will say that we want to keep the columns that won't be applied transformation, that won't be one hot encoded, which are age and salary columns. If we don't include this remainder equals pass-through here, then when we apply the transformation on X, we will only keep the first three columns resulting from one hot encoding. And of course, we want to keep age and salary columns into our resultant matrix of features. So that is why we are setting it to pass through. Now we have our city object. It is of course not connected yet to our matrix of features X, and that is exactly what we want to do next. This time we don't have to do it in two steps. By first calling a fit method on the object to connect our object to the matrix of features X, and then applying the transform method to apply the transformation. This time we can do it in one step because the column transformer class actually has a method called fit transform. It combines the fit and transform steps into a single call. It will do the process of fitting and transforming two steps in the same single call. So ct dot fit transform. Pass matrix of features X, which is what we want to transform. This fit transform method will return as output the new matrix of features X with the one hot encoded country column. Now we are going to update this new matrix of features X. The fit transform method does not return the output as a numpy array, and it is absolutely compulsory to have X as a numpy array because this will be expected by the future machine learning models which we are going to build. So here we want to force the output of this fit transform method to be a numpy array. And to do this, we simply need to call numpy first, which has a shortcut name np, from which we are going to call this array function, which will take as input the output of the fit transform method. We have applied this transformation one hot encoding to the country column of the matrix of features X. Let's check this by creating a new code cell and then printing this matrix. Add a new code cell and print X. Now let's run this cell. Run this cell and then running the next one. And what do we see here? Well, we see exactly what was expected here, meaning that we no longer have the first country column with the string values. Now we have three new columns where each row encodes one of the three countries. France is encoded as vector of 1, 0, 0. Then Spain is encoded as 0, 0, 1. And the Germany is encoded as a vector of 0, 1, 0. And that is exactly the idea of one hot encoding. We not only converted our country column values into numerical values, but also there is no any numerical order. Now we are going to do encoding for the dependent variable purchased. We are going to use another class called label encoder, and which will exactly encode these no and yes labels into zeros and ones respectively. And now let's encode the dependent variable y. Let's create a new code cell. Import label encoder from pre-processing module of scikit-learn. From sklearn dot pre-processing import label encoder. Create an object of this class. le equals to create an instance of label encoder. We don't have to input anything in the parentheses because y is only one single vector. So it will be obvious what we will be needed to encode. Once again, there is a fit transform method which we can call on le and pass y. le dot fit transform and pass y. We can set the y to what is returned by the fit transform method. Y equals to. Now let's check this. Let's create a new code cell just to print our dependent variable vector y. Print y. Run the cells. Run print y. And we get zeros and ones. 0 corresponds to no and 1 corresponds to yes. Now you not only know how to apply one hot encoding when you have several categories and one of the features of your matrix of features, but also you can do a simple label encoding when you have two classes which you can directly encode into zeros and ones, a binary outcome. Now you have one more tool in your data pre-processing toolkit, which is to encode categorical variables. And now we are going to move on to the next step, which will be to split the data set into the training set and the test set. Let's proceed to the next tool in our data pre-processing toolkit, which is about splitting the data set into the training set and the test set. Add code cell. Import train test split from model selection module of scikit-learn. From sklearn model selection, import, train, test split. Now call the train test split function. Pass x as first parameter and y as second parameter. Next parameter is test size. Set it to 0.2. 0.2 means 20%. If it is set to float, it should be between 0.0 to 1.0. That represents the proportion of the data set to include in the test split. If it is int, that represents the absolute number of test samples. Next parameter is random state. Set random state to any number. I'm setting it to 42. It controls the shuffling applied to the data before applying the split. Pass an int for reproducible output across multiple function calls. This function returns a list containing train test split of inputs. So we are basically going to get 4 sets. X train, X test, Y train, and Y test. X train is the matrix of features of the training set. X test is the matrix of features of the test set. Y train is the dependable variable of the training set. And Y test is the dependent variable of the test set. Let's check these 4 new sets. Add code cell to check these 4 sets. Print X train, create 3 more code cells. X test, print Y train and Y test. Now let's execute everything starting with this cell, splitting the data set into training set and test set. Now run X, print X train. You can see we have 8 observations in this training set, which correspond to 8 customers taken randomly from the data set. And we clearly recognize the features here with first 3 columns being the one hot encoded variables. We also call them dummy variables. Then we have here age as the second variable, and then we have salary. So we clearly have a matrix of features for the training set. Now run X test. Here we have 2 observations containing the same features. This is the matrix of features for the test set. Run Y train. Here we have 8 purchased decisions with the zeros and ones that were encoded before with label encoder. These 8 purchase decisions correspond to the 8 same customers of the matrix of features X train of the training set. And finally, execute Y test. Here we have 2 purchased decisions corresponding to the same customers as in the matrix of features of the test set X test. Now you have one more tool in your data preprocessing toolkit to split the data set into the training set and the test set. And now we are going to move on to the final step, feature scaling. Let's proceed to the final tool in our data preprocessing toolkit, which is feature scaling, which will allow to put all our features on the same scale. Feature scaling is a critical preprocessing step that ensures all numerical features contribute equally to a model, preventing variables with larger magnitudes from dominating the learning process. We will apply feature scaling on xtrain and xtest separately. Actually, the scaler will be fitted to only xtrain and then we will transform xtest. Now let's proceed to the implementation of feature scaling. The tool that we are going to use is a class called standard scaler, in which we will exactly perform standardization on both the matrix of features of training set and the matrix of features of the test set. Add a code cell. Import standard scaler from pre-processing module of scikit-learn. From sklearn dot pre-processing module, import standard scaler. And next statement, create an object of standard scaler. Don't apply feature scaling to your dummy variables. Only apply feature scaling to your numerical values. In our dataset, we have some variables taking values in a very different range, right? The age goes between 0 and 100 and the salary goes between 0 and 100,000. Now next step is to apply feature scaling to our matrices of features, xtrain and xtest. So first of all, we are going to fit our scaler on the training set. Scaler dot fit transform and pass x train all rows and all columns starting index 3, which means age and salary. Fit will just compute the mean and standard deviation of each of your features, and transform will apply this formula to transform your values so that they are all on the same scale. Then set xtrain same features to the returned value. This will apply feature scaling to our two columns, age and salary of the training set. Now we have to also transform our matrix of features of the test set, xtest. But since this data is like new data, I will only apply the transform method because the features of the test set need to be scaled by the same scaler that was fitted and used on the training set. So copy this and paste here x test all rows, same columns, age and salary columns, call transform x test all rows and same columns. Let's check xtrain and xtest. Add code cells. Print x train and print xtest. Now let's execute everything starting with this cell. Scaling age and salary of the training set and the test set. Execute this. Now execute print xtrain and execute print xtest. Now we can see the dummy variables still have the same values 1.0, 0.0, 0.0, but our age and salary variables have been transformed. Okay, this is age column and this is salary column. Okay, these two columns have been transformed so that they take new values between -2 and +2. Sometimes you will see values between -3 and +3. But anyway, now all your variables are on the same scale, and this will be perfect to improve the training of certain machine learning models. Congratulations, you really nailed the lesson on this data preprocessing toolkit. And now we are 100% ready to start building machine learning models that will perform amazing predictions. If you enjoyed this video and want to see more like this, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below. I look forward to seeing you back in the next video. And until then, enjoy machine learning.